So for this lecture video, we're going to learn about how to convert mass to mole in a stoichiometry problem solving. So as always, in any stoichiometry conversion, you're always given first a balanced chemical equation that has all the substances that may be mentioned in the problem that you're going to solve. So let's begin looking at problem number 1, and let's follow the outline illustrated here to be able to solve the problem. So let's read carefully the problem so we know what we need to do. So it says that if there are 340.56 grams of HBr, how many moles of KBr will you get? At the same time, you are given the molar mass of HBr, which is 80.91 grams per mole. So these three things are the important details that you need to remember as you analyze the problem. Now, because it's called mass to mole, so you notice that the given is grams, which is the mass, and then you are asked for the moles in this kind of problem. So that's why it's titled mass to mole. Given the grams, that's the mass, and you are asked to solve for the moles. So this is a mass to mole calculation. So as always, the first step is we need to write the given mass, the whole thing including the substance. So our given is 340.56 grams, and then HBr is our substance. Okay? Then after that, we're going to multiply it. This time, the next step is the molar mass. Okay? Molar mass is the next step. Where do we get again the molar mass? The molar mass comes from the given. So there's the molar mass of HBr there. So the molar mass given is always the molar mass of the substance also in the given. They should be the same. And so, how do we put in the molar mass values for this case? Now, remember that our given is in grams HBr, and we need to cancel the grams HBr in the given. So therefore, the 80.91 grams in the molar mass should be placed at the bottom. Again, the reason for that is we need to cancel the gram HBr in the given. So to be able to cancel that, we need to have another gram at the bottom. So this is our 80.91 grams HBr. And we know that the partner of grams HBr in a molar mass is always your 1 mole HBr. That's according to the definition of molar mass, which is the mass in grams of 1 mole of any substance. So that 1 mole is up there. And it will always be that the mole is valued as 1 if we're talking about molar mass. Nothing else. It's always 1 mole there. And this value here, we just copied it from the given. And don't ever forget that we should be putting that value at the bottom. The reason, again, mathematically, is we need to cancel the unit from the given through that similar unit at the bottom. So you can see grams HBr and grams HBr gets to cancel out. After the molar mass part, we are now ready to calculate for the mole ratio. So you put multiplication, and then we're going to put a parenthesis again for the mole ratio. Then we separate it with a line. So same concept with the mole ratio. We have to have a substance at the bottom and at the top. Same idea. The one at the bottom should be the same as the given, which is HBr, right? So the one at the bottom should be similar to the given, which is HBr. And the one at the top is what you are solving. The one you're solving is KBr. KBr is different than HBr. So KBr is the one being asked in the problem. So we put it up there. Once we figure out what substances have to be placed up and down, we're ready to look at the balanced chemical equation for the mole ratio values. So all we need to do is find for HBr first. Where is HBr? Okay, HBr is here, and the coefficient is 6. So therefore, that will be 6 moles beside HBr. And we do the same for KBr. KBr is here. All you need to do is get the coefficient of that substance, which is 7 in here. So that means that will be 7 moles beside KBr. And you see that there are units that get cancelled here. The mole HBr and the mole HBr are the same. One is top and the other is at the bottom. So therefore you can cancel that unit as well. After we cancel the units that we don't need, I need us to check the top, the remaining uncancelled unit. It's moles KBr. Then you ask yourself, does it match with the question of the problem? The question is how many moles of KBr? And the unit at the top that is not cancelled is also moles KBr. That means your solution covers the question, and it will answer your question eventually the moment we go to the answer. But the point is, this unit that remains uncancelled should match with the question. It should answer the question of the problem. So once we know that the solution is now complete, we are now ready to do the calculation. So mathematically, we have to group all the numbers, all the ones at the top and all the ones at the bottom, so we get the accurate answer. The given is included with the top values. So when we go to the top, we always begin by writing your given value, 340.56, then times 1. Although the times 1, you can skip this. I'll just emphasize it here that it's included, but mathematically you know that it's going to generate the same answer. And then after that times 7. Close the parentheses. And then divided by whatever remains at the bottom, you put them at the bottom. So that's 80.91 and then times 6 right there. Okay? So if you're having only the ordinary calculator, so please multiply first all the ones at the top and then multiply all the ones at the bottom separately and write all the products that you get on the paper. So let's calculate the top first. That's 340.56 times 1, which you don't have to input that in the calculator, and then times 7. So in the calculator you will get 2,383.92 as the product of the values at the top. And then after the top, we're now going to multiply the ones at the bottom. So that's 80.91 times 6. The product, the whole product is 485.46. Please check from your end. I hope that you're also calculating so that we will match our answers. And if there are discrepancies, please ask about it. So once you got the product from the top and bottom, it's now time to divide the two values, making sure that the top is always inputted first, then divided by the bottom. So 2,383.92 divided by 485.46. Then we press the enter. When we press the enter, there's a lot of values there. We'll just stick with the two decimal places that we're used to. So that's going to be 4.91. So 4.91. And the final unit, the complete unit of our value, will follow the unit at the top, which is the one being asked in the problem. So that's 4.91 moles KBr. And that completes our first problem for the